G'day Bifrosters. So here's what we're going to do today. The bits in green, and what the bits in green are, we've got a new way of bringing in our master curves. We've put everything into a nice tidy package for our controls and our limiting of controls. And we're going to add our random and rotation today. And then if we've got any time left over, we might start looking at the sag, but that's possibly for another time. So let's go back to what we had and we'll rebuild this. That's F5, we want F4. Do not save because I've already saved it. So when I last left you, this is kind of what we had. Let's get this looking a bit easier to see. And since then, I have found a nice little fix for this, so I'm going to rebuild this back. We're going to rebuild this curve back to 12. Maybe if we selected the curve. Let's rebuild this back to 12. Lovely. Now when I say I found a good solution for this, it wasn't me. It was a magnificent bastard on the Slack channels. A magnificent bastard by the name of Noel. Noel Winson. Thank you, sir. This is a great fix. So you remember how I was having problems here with the curve and the rebuilt master curve not really matching, not playing well, not having a good time together. Okay, so here's the fix for that. I'm going to need an outliner, and I'm going to need to bring in these paths one by one. Yeah, and to bring in something one by one, you just do it one by one like this. 1, 1, and 1. So these are our master curves, and you know, if you're building this for yourself or in your own studio, you can add any curves. You can write a script to add a curve for you. You can do all that kind of thing. What I'm going to do here is I'm just going to build an array of these. We'll get to the tricky bit in a minute. So we'll get that, and that, and that. And we're going to replace our curve in array, which I believe is all of these except that one. So those two. We're going to replace our curve in array with this array. So we'll pop that one there. And we'll pop that one there. Because we want to keep our, we want to keep our functionality. And let's just find the curvy one. That's going to be this guy. Well, technically it's going to be this control, which means we need to rob ourselves of some more real estate. And select the Bifröst. And change our curve selection to 1. There we go. So all of this is in aid of basically getting a smoother curve. And the way we can do that, I believe this is curve 2, master curve 2. Go to parameters here, let's close this down for now. And change the segment multiplier. Look at that. So even though now this curve is still happily playing around with 12 points, I have multiplied that 12 by 30. Which is great. Possibly means we can lose the rebuild. I haven't tested that. That might be something to test. But what we can definitely lose is that, because that's not doing anything anymore. So what happens if well, no, I don't want to lose the rebuild, because the rebuild, now I think about it, controls how many poles we have as well. So let's just double check to make sure that's working. We'll select our Bifröst and we'll do our instance count, and that's looking pretty nice. And it doesn't go below 3, which is great. Okay, so that's the first thing we were going to do, and we've done it. Thank you, Noel. This is awesome. And if we're worried about the way it looks, we can just mess around with this. Now, because of the segment multiplier, this works nicely. We can also space them out a bit more evenly if you like. And all I'll do is I'll go in here and do the same for all of these. So let's go 10 and 10 and 10. We'll just leave that there. That is now done. So this makes a difference in our node editor, in that you can see that the master curve shapes, instead of going into a single point now, they're each going into a separate input, which is fine. which is absolutely fine. I'm sure that there's other ways and better ways to do it. If you find them, please let me know what they are. The next thing we're going to do is put these guys in their own compound, basically. And this is really just for tidiness. I'm going to do the control limits. And if you remember in here, we'll lay this out. So we have our instance control, we have our selection control. The instance control just makes sure it doesn't fall below 3. Selection control makes sure it doesn't go above the top of the selection or below the bottom of the selection. So we'll just rename those to instance control. Oh, it didn't like that. You know why it didn't like that? Because those two are the same. So let's fix that. And this is selection control. That's 2 of our nice green boxes done. And now we get on to something with a bit more meat. So that was just a bit of housekeeping stuff I've learnt since I last did one of these installments, which I know has been a bit long, but I do have quite a lot of tutorials on the board right now. So let's avoid some confusion. We'll get rid of that. We don't need that anymore. Let's pop that down here. Now, if you remember, what we're doing is we are getting in an array of curves. Input curve array. All good. This is where we select our curve, and then we start to do things to it. So what we remember, if you remember what we did, we resampled the strands. We got the strands basis, which gets us point tangent, point normal, and point binormal. And then we converted that to orientation. And this is what does our rotation along the curve. So what we're going to do now is actually add to that. So let's throw this out to, let's make a little compound to do it. So these two are our inputs of objects coming in. We don't want to do it here. What we do want to do is something here, and we want to make a rotate. So I'm just going to add a value for now, just to hold a place. And that value is going to be a vector. Set port type, vector 3. Okie dokie. And this is going to be our rotation. Great. Let's take that and we'll smack that into a compound like this. We're just trying to keep everything tidy and modular. We're working our way up to a more modular rig that we can pass off. So I'm just going to call this rotations calc. So we're going to calculate our rotations in there. So in here we need to do a couple of things. Bifröst works in radians like most 3D packages do, and humans tend to work in degrees, especially artists. Riggers and tech artists might work in radians, but artists tend to be far more comfortable and far more competent using 0 to 360 using degrees. So what I'm going to do is I'm going to assume that this is degrees, and I'm not going to be able to spell anything today. I'm just going to do a real quick degrees to radians, pop that out. Give it a name. Then we're going to come over here, we're going to plug this into rotate radians. So let's get our Bifröst selected. Now we've got rotation X, Y, and Z. So what happens if I play with them? Well, everything rotates along whatever axis we asked it to in that specified axis. So this is rotating in the X. This is rotating in the Z. And here's our Y rotation. And this is just that. This is just adding to the rotation that's already there. But it's a good control to have because it allows for a lot of fine control for our artists. So, you know, if they need to do some sort of weirdly apocalyptic thing, they might want to lean everything over. The only thing is this is going to rotate them the same amount across the entire curve. So this is where we come to our second control. I'm going to do it in here in the rotations calculate. And it's going to be a random control. And this needs a little more setup. So let's do a value. Let's make that value a vector. We'll plug that in there and delete this like that. And we'll call this randomization. This is just for randomizing the rotations, but we know what it is. So I'm just going to plug that straight into here. Again, we're going to keep it clean. So what we're going to end up doing is adding these two together and popping them out. And so again, I'm going to assume that these are degrees, and the first thing I'm going to do is convert them to radians, just like the other one. But this isn't a random number. This is whatever our artists put in here. So what we basically need to do is we need to do first off, we need to see if it's positive or negative. All right. Do we? Maybe we don't. Let's try it without. But we need to have an array coming out to plug into here. Let's just get this down so it's not confusing us. So one thing I'm going to need to do for that straight away is I'm going to need to know the number of points. So the number of instance points I have on my curve, more or less, which we are already getting here. If you see the constant count, that one, we're already getting that. So we can just straight up use that, because that's the number of points in our that we want our input curve to be. So what we'll do is we'll take this one, pop it in here, and we'll just call this instance count. Jump back in here. So this good start, not going to be what we need. What we going to need is a random value array. And the reason I brought this in is because the random value array needs a size. And it also needs an offset. For the offset, I'm just going to use a value, because this will come in handy later. That value will be a vector 3 and 0, 0, 0, like this. And we've got a seed coming in that we can use. So now we have as many random values as we want coming into this. Well, not coming in, sorry. We have as many random values as we like, which in this case is the instance count. We have that many random values between 0 and 1 being generated in here. And what I'm going to do now is a set range. Set range is one of my nodes, and it's really simple. It just gets the array bounds of whatever's coming in, sets that to the from start from end, and then sets the min and max based on what you've come in. So I'm going to use this one, but feel free to build your own. Obviously it works with vector arrays. The minimum's always going to be 0. So it's a random number between 0 and something. And it's going to be a random number between 0 and whatever our users enter. And then we're going to add it to the output like that. And that'll go off and happily be random. So what happens now if I rotate Z? Not terribly much right now. That's not making me happy. Nothing like a bit of troubleshooting, right? Nothing's coming through here, which leads me to believe, yep, there we go, that it's not hooked up. Okay, that explains a bit. There we go. So if you have a look, you can see that some of these poles are leaned over quite a way, and some of them aren't. And this gives you basically a little bit of randomization that you can do this. You see that some poles change, some poles don't, which just means that for these poles they're getting a 0 randomization. I can change that by changing my seed that I'm bringing into my rotation controls, which means I should probably put it out to our main controls. This is our main controls here. Let's put it out there. Let's see what happens if I just play with the seed. So you can see that they're all rotating in the Z based on the number here that we gave it in randomization, and then we're just using the seed to generate a different random number every time. So let's check the other ones. Have we got, let's zero this. We'll zero all of these out. Like so. We'll check our rotation X first. This is everything is rotating at the same amount. And that's deliberate. That's if I want to get a lean or if I want to do something to every single one. Also why we have two controls. So that's working nicely. And Z for reasons that are to become obvious. Yep. That's working. And Y. Lovely. Everything's rotating. All of the strands are behaving themselves along the same way. That's exactly what we want. Now let's randomize it. So what happens if I randomize the X? And then I've got different leans going for different places and things like that. And the Y, yep, nicely random going on. I can change the seed to get a change out of those. And then for randomization Z, let's go back the other way. That's pretty good too. The only thing I would possibly change is instead of, we'll get rid of these watch points. Since we were playing in a compound that wasn't hooked up, that's completely on me and I accept all responsibility for it. The only thing that I would possibly change is I would like to try, instead of going at 0 rotation for minimum, let's take this, negate it, which just means if it's positive, make it negative. If it's negative, make it positive. So flip the sign and plug that in. That way, you've got, you see they're moving in different directions now. Let's zero those out. So this is kind of a bit of a, I guess it's a preference for you, for how you want to build it. If you want to have a randomization that goes in both directions, you can see that, like so, then hook up the negated input to the minimum. If you just want to have it go in one direction, depending on your control, then hook up the 0. And see they're all going random amounts in one direction. In this case, it's positive, so they're all leaning down towards their right. And then when it's negative, they go the other way. That's up to you. I'm going to go with the negate method because I quite like it. I'm going to zero everything out. Like this and this. And so now we've got one of our major controls in. So let's do a bit of housekeeping. First off, we'll save it. And in my case, I should save it as, because I'm doing a different episode now. Save as 5. That's cool. So this way I can give it to you guys on the server. Okay, so let's go ahead and make the sag. Now, if you think about it, what we have here, if we take a look at this, we have an array of 84 things. We know they're strands. We know that they're the strands on the wires. We know that they're obeying the attachment points nicely, and everybody's happy. If we come before this array, you can see that it's size 4. What that means is that it's an array of the wires. So this is an array of the strands that make up the wires. We're going to need to loop through that. So let's do a for each. So what this will do is it will loop through each strand. It might be this one here. It might be this one here. Doesn't matter. We're going to loop through it. So we plug that into there. There's our flattened array. We'll set this as the port iteration target so that this is what it loops over. So whatever it does in here, it's doing to every single one of these strands in between the attachment points, and it's doing it one at a time. So it's doing that one, then 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 that one, that one. You get the idea. Okay. First thing I'm going to need from this is update. No, it's not. The first thing I'm going to need to do is resample the strand. And this is going to become a control. So we're going to stick this back out through the input in a minute. We're going to make sure it's not a spatial resample. Because if you're working on, say, real world, or bigger than real world, files and you try to plug that into it, you're going to be waiting an awfully long time for it to do its thing. What I'm going to use is constant count, and I'm going to set that to 24 right now because it's a nice round number. I'm going to plug this back out as a control and it will carry that 24 for me. See, I'm going to rename that to, not even resample wire, we'll call this wire resolution. We can go back and change that later, but so for now what we've got is still a straight line at this point. We've gotten one of our strands and we're resampling it to have 24 points. Then I'm going to do update strands ratio. And what this is going to do is take each one of those points and assign it a number based on where it is at the beginning and the end, or where it is in relation to the beginning and the end point of the strand. So say for example this point here on this strand might be 0 and this one over here will be 1. We resample it to 24, so now this point here is 0 and this point here is 24. What this will do, well, it will give me the ratio of the point number to the number of points. So we've done 24, so technically that will be point 23 and that will be point 0. So the first point, the ratio will be 0 because the total number of points, 23, 0 divided by the number of points is still 0. And then say we take the halfway point, the 12th point, then we're going to get 0.5 because 12 divided by 23, or 12 divided by 24, 11 divided by 23, whatever, it'll be 0.5. And you see, you'll build up a ratio that starts at 0 at the beginning, the 0 point, and ends at 1 on the last point. And that becomes incredibly useful for what we want to do. Because this is what we're going to add our sag value to. Well, multiply our sag value by, and this is also what we're going to add our curve to that gives us the shape of the sag. And we take advantage of the strand ratio to do that. So let's go ahead and do that right now. So I have a curve here that I prepared earlier. So this is just an F curve. It's a value node with an F curve in it. That F curve starts at 0, goes to -1 at 0.5 and goes back up to 0. So it's hanging. It's going downwards. This is how I fake this. There is a mathematical constant called catenary curves, which I haven't quite worked out yet, and a friend of mine is helping me work that out right now. So this might get an update later. But for now, I am literally doing the good old computer graphics traditional way of cheating the hell out of it. So I'm going to take this guy and I'm going to evaluate F curve. Always goes into the wrong one first, goes and put that into X. We're going to put our curve in there. And now we need a value to sag it by. So let's make a float here. So this is what we're going to use to actually make the sag. So we'll plug in a float, delete our value, call this sag value. We're not going to do any randoms just yet. We're just going to try and get the sag working. Okay, so we're going to take our sag value and we're going to multiply that sag value by this curve we've just built here. And we're going to go away from that and come back to it. So at the moment, this is just taking our sag curve, which looks like that, and multiplying these ratios by the curve and then multiplying that whole thing. So basically what this curve is doing is depending on where the ratio is, it's changing it and then multiplying it by the value we want to add as a sag value. So now what we do is we get the positions of each of these. Get point positions here. So this is the position of each point. So kind of obviously. And we're going to convert that over to a scalar. So vector to scalar, vector 3 to scalar, because the x position and the y position are going to be just fine. Sorry, not the y, because the x position and the z position, so this axis here, we don't want that to change at all. The x position and the z position give us the curve from each attachment point. So that's no touchy. We don't want to touch that one at all. What we want to do is we want to use this number for our Y. So really all we're going to do is we're going to add this number to our Y. Remember, there'll be more things we're putting in. This is like everything else, we're just getting the concepts working. And then we convert it all back into a vector. Scale it to vector 3 with our X to our X, our Z to our Z, and our Y to our Y. And that goes out to the output. Okay? So hopefully you followed that along. We have each of these coming in, and remember it's each one between each attachment point coming in. We've got a sag amount. Let's give it one. Let's say like 0.5, just to see what it does right now. It's not going to do anything until I hook it up. We have a sag value. We resample our strands to get some resolution along those lines, because right now there's 2 points. That curve's not going to do anything. We then get our strands ratio. We multiply that, well, we evaluate this curve on it. Then we multiply that by the amount we want them to sag and add that to our Y position. And then we make everything back into a vector and out we go. So that's great for now. This is going to be our new strands. Right now these strands, these ones here, coming straight out of the nested array, they're our flat strands. So I actually need to construct some strands again. Like that. There's our point position. And there's our strands. And you can see, there we go. Or maybe we could just delete the fact that this loop is only going round 10 times because it has a max iteration. So let's delete that port and see what happens. And we have sag. We have our sag working nicely. So let's check to see that we can change that. I'm going to hook up our strand point count to our main controls, which is way back up here, but that's all right. And I'm also, at the same time, I'm going to hook up our sag value. So now we've got a sag value and strand point count. They're going to both be set to 0 right now because that's what happens when you hook up a new control. Let's be careful with this. We'll set this to 24 for now, and they will come back. That's lovely. There's no sag, as you can see, so they're all dead straight. So that's, so far, that's working quite nicely. Let's take our sag. Look at that. You can even go below 0 if you want to. But now we can have saggy wires, or we can have nice tight wires. And it's just applying that curve to every single strand. And don't forget, the strands started off being one strand that went along the entire path. Right now we have we're getting fairly close to a final product. We need to add some nice things, some things to make it nicer. So we need to add things like maybe you don't want every single strand to look exactly the same. Perhaps we want to have the ability to randomize the strands and then randomize the sag. We already have the ability to lose any of the wires that we don't want. So a number of wires, we can just get rid of those or bring them back as we like. That's all good. With the sag on, does it still work with everything? So if I rotate stuff, yep, that works pretty nicely. It's doing its job nice. What about if I rotate this way? Yeah, that seems to be holding pretty nicely. And it's because of that ratio that it's changing to match. So that's a really good thing to have. Is in Houdini it's called curve view. It's just a value along the curve representing how far along the curve you are. Here it's called strands ratio, but you can call it whatever you like. You can call it George if you like. I'll just check that it works this way with a bit of twist. And yeah, those wires are working pretty nicely there. So I'm happy with that. I'm going to leave it there because that's getting in a main component, or two actually in this video, which is in terms of the rotation and the random rotations. and then also the sag on the wires. So let's run through real quick what we did, and then I'll let you go. First thing we did is we changed the way the curves come in so that we could take advantage of the segment multiplier, which was given to me by a magnificent bugger on the forums, who I'm very, very thankful to. Everybody give a great big round of applause to Noel Winson. Much thanks. Then we just tidied up our controls a bit so that, well, not even our controls, we tidied up the way we were limiting the number of the instance count and things like that, so that we couldn't drop below 2 and break the entire thing. And also so that we couldn't say I want curve number 340 and there's only 2 curves in there. It's just a bit of tidying up. Then we went through and we did our rotations, and we did it all in one compound called rotations calc. So what we did is we had our rotation come in, we converted it to radians, and then we just output that. That was the first thing we did, and then we plugged that into rotate radians in our strands basis to orientation, and that lets you rotate by some radians in here, and it affects all of this. It's nice. Then back in our rotations calc, we added a random value. We tried to do a single value, and that didn't really work. We worked out we needed to do an array, and we needed to do an array of the same number as the instances, because if I now change the instance count here, those random rotations still apply, because we need to do it to every single one in this array. So we built a random value array with an offset of 0, 0, 0, which just means it's between 0 and 1 as a vector. We plugged that into our set range, which remember was just a node that took the bounds of the incoming array and then changed the range from those bounds to whatever you put in. We then added that to our rotational radians, which we made first, output that, and that was already going into, where are we? It's along here somewhere. No, I've gone too far. Yeah, into our strands basis here. So now we can control all of our rotations and our random rotations in one clean compound just here, and that just gets applied in the strands basis orientation. And then we were done. We were like, okay, so let's get on to the sag. Let's try and get the sag working. The sag was a little bit more complicated, because at this point we were pretty much just, where were we? We were here. So when we left last time, we had straight lines going between every pole. We made a new compound here, and into that compound we took out our nested array, so our array of wires. We then updated the ratio. Oh, before that, sorry, we resampled the strands, and then we had a new control, which is our count. So how many points in these, because, doing it for film is going to be different for doing it to a game engine. You might want 250 points in each curve. For a film project, you might want 25 in each curve for a games project. And it just gives us control. And so we resampled the strands by that number. We got the ratio of the strands and applied our master sag curve to them. And this is just a curve I prepared earlier with the settings of 0, 0, 0, 1, and then minus 1.5. And that gives us it's essentially a 3-point Bezier. But it looks okay, and it allows us to edit it if we want to later. So we applied that to our ratio. We multiplied that by the sag amount that we set up. And the sag amount is just quite literally how much would you like it to sag. And I haven't put any, you can make them go crazy if you like. But it just sags everything based on that curve by that amount. When we add it into the Y value of this resampled strands that we made. Remember, this resampled strands, this is a loop, and what's coming into this loop is all of the strands. So at this point they were like, that was one, and then that was another, and that was another. There was quite a lot of them. We looped through each one, and we did this to every single one. Resampled, got ratio, applied curve, multiplied by the sag amount, and added to the Y value of the points in that strand, spat out the points again. Then we constructed strands for those points. Let me just get rid of that watch point, and they became our new wires. So let's rename This, I believe, is our instances. So this is going to be poles. And this is going to be wires. So that's it. That's part 5. In part 6, we're going to start adding all of the things that make something just a little more special and a little more randomized and a little more, make it look right. And then maybe in the part after that we'll talk about adding custom points. Alright, hope this has helped. See you later.